students.
Good morning, sir.
Good morning.
Good morning, sir.
First of all, wish you good luck in your PG entrance exams. I hope you have bright future when you do the chemistry in your PG subject compared to other subjects, because there are a lot of opportunities when you do MSc chemistry and later on PhD, etc. So definitely you have bright career if you choose chemistry as one of the PG subject.
సార్ నేను లీవ్ అవ్వచ్చా సార్?
హోస్ట్
Sir.
చేశారు, స్క్రీన్ షేర్ చేయొచ్చా?
చేస్తున్నా సార్, ఒక్క నిమిషం చేసి నేను లీవ్ అవుతున్నాను చెప్దామని
Okay.
మిమ్మల్ని హోస్ట్ చేస్తున్నాను.
ఓకే,
మిమ్మల్ని
Okay.
హోస్ట్ చేశాను, మీరు షేర్ చేసేస్తారు.
ఓకే, ఓకే, థ్యాంక్ యూ సార్, థ్యాంక్ యూ.
ఓకే సార్, రైట్. నేను లీవ్ అవుతున్నా సార్.
ఓకే, షూర్. Once again, good morning, very good morning, dear students.
Good morning, sir.
Good morning,
Good
sir.
morning, sir.
Now today we are going to discuss two simple topics. Though they are simple topics, we can expect, as Ashok sir said, 3 to 4 questions. So mostly these are all these topics theoretical based. Only few numerical problems we can expect. Simple numerical problems we can
సార్
expect.
ఏమైనా సార్
Sir,
ఏమైనా షేర్ చేశారా?
చేస్తాను.
అదే మరి ఏం షేరింగ్ వస్తలేదు, మన డౌట్ వచ్చింది.
చెక్ చేయమంటారా సరే?
అదే షేర్ చేస్తే ఇక పిల్లలకి అంటే వస్తుందా లేదా మళ్ళీ ఒకసారి చెక్ చేసుకోండి.
ఓకే, ఓకే, షూర్.
రండి.
అవుతుందా సార్?
సార్ ఇంకా రాలేదు, వెయిటింగ్.
Good morning.
Good morning, Ramesh bhai. Thank you very much for giving this opportunity to interact with students.
Leaning వారికి నోట్స్ కూడా పెట్టాను, నోట్స్ కూడా షేర్ చేద్దాం.
ఓకే, షూర్, షేర్ చేస్తాను.
రైట్.
షేర్ అవుతుందా అశోక్ సార్?
ఇంకా రాలేదు సార్, ఏమీ రాలేదు, షేరింగ్ రాలేదు. ఫస్ట్ అది మీ పిపిటి డెస్క్టాప్ మీద ఉందా సార్ ప్రెజెంటేషన్?
ఫోన్ మీదనే ఉంది.
ఓకే, ఒకసారి షేర్ చేయండి.
అవుతుందా సార్?
ఇంకా ఏం రాలేదు సార్. స్టూడెంట్స్, ఈజ్ ఇట్ విజిబుల్ ఎనీ ప్రెజెంటేషన్?
No, sir.
No, sir.
కూడా కనపడుతుంది కదా. మరి ఎట్లా ల్యాప్టాప్
అలే ఫోనే భయ.
మీరు
చేసిన పోస్ట్ చేసిన సార్.
కరియన్, థ్యాంక్ యూ.
ఓకే, అవుతుందా సార్?
నాకైతే ఏం వస్తలేదు సార్. మరి
No, sir.
మీకు ఓపెన్ అవుతుందా సార్? మీకు షేరింగ్ ఓపెన్ అవుతుందా సార్?
అవుతుంది. అల్లో డిస్ప్లే ఓవర్ ది యాప్స్ అని వస్తుంది.
మీకు డిస్ప్లే వస్తుందా?
ఒక్క నిమిషం. అయితే మీకు వాట్సాప్ లో పెడతాను, షేర్ చేస్తారా సరే?
అవునా, వాట్సాప్ ఇప్పుడు వస్తుంది సార్. ఓకే
సార్ వస్తుంది సార్.
ఇప్పుడు వచ్చింది సార్.
ఓకే,
ఇప్పుడు షేర్ చేయండి.
నౌ
ఓకే, వచ్చింది.
రైట్, థ్యాంక్ యూ.
వచ్చింది సార్. ఓకే,
రైట్
రైట్ సార్, రైట్.
సో
నేను లీవ్ అవుతున్నా సార్ మరి.
Okay. All of you mute yourself. If you have any doubt or anything you cannot understand, please send a message in chat box. Okay, is it okay?
Okay, sir. Okay, sir.
Photochemistry. So you might have studied some of the aspects with respect to photochemistry. And photo means light. And we study a lot with respect to chemistry. Means the reactions, whether it is physical processes or chemical processes. Now it's a branch of science which deals with chemical reactions caused by absorption of radiations of UV and visible region. So basically, primarily, we can say a definition of photochemistry. If anybody asks, what is photochemistry? Simply, the interaction of light with the matter. So we study the chemical reactions caused by absorption of radiations, UV as well as visible region. Now you know the wavelength of this region is 8,000 angstroms to 2,000 angstrom unit, visible as well as UV region. Now photon being the primary unit of radiation. Now we say photons, generally we write as h nu. So we write symbol with h nu, where h is the Planck's constant and nu is the frequency of that light or radiation. And we also say that the light has electromagnetic radiation. Now we study the reactions generally in photochemical reactions or by involving light, either combination reactions, oxidation reactions, reduction reactions, decomposition reactions, hydrolysis reactions, polymerization reactions. So we can study all these reactions which involving the light. Photochemical reactions are accompanied by increase in free energy. Generally, am I audible to all of you?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir, my voice is clear?
Yes, sir.
Yes,
Okay,
sir.
sure. So, photochemical reactions are accompanied by increase in free energy. So, normally, the other reactions, what are other reactions? The reactions which takes place in presence of heat energy. They are called thermal reactions. So, in thermal reaction, generally, the free energy, that is Gibbs free energy, decreases. But contrary to that, in photochemical reactions, these are accompanied by increase in free energy. So that is the basic difference between thermal reactions and photochemical reactions. So you can see the best example, a natural example of photochemical reaction, or the photochemistry involving the photosynthesis, where the free energy increases. This is a best example for photochemical reactions. So we can also say other chemical reactions, other photochemical reactions. We see later the examples. Now, in thermal reactions, reactants undergo chemical reaction if they acquire activation energy by collision. So normally, what mechanism takes place in thermal reactions? You can observe, you know something that the molecular collisions takes place in reactions, and due to that molecular collisions, the reactant molecule reaches the activation energy. So then only they convert into product. Photochemical reactions depend on an outside source for energy. The absorption of radiation is always quantized, that is integers 1, 2, 3, etc. The energy levels of absorption radiation is quantized. A quantum of energy which is absorbed is called a photon. A quantum of energy which is absorbed is called a photon. It depends on frequency of radiation. So this is another point we have to understand. That is, a quantum of energy which is absorbed is called a photon. Now it depends on frequency of radiation. So E equal to H nu, or equal to, so we can write in different forms this equation. That's a Max Planck's equation, energy equation, which tells about the photon of radiation. So these three equations, you can see H nu, Hc by lambda, Hc nu bar. So where you can see H Planck's constant, nu frequency, c velocity of light, and nu bar is the wave number. The absorption of a photon of light may raise a molecule to an excited electronic state. Here the terminology is different compared to thermal reactions. So there we use activation energy. Here, when the molecules absorbs photon, they the excited molecule enters into excited electronic state, so which involves promotion of an electron from bonding molecular orbital to anti-bonding molecular orbital. So promotion of an electron from bonding molecular orbital to anti-bonding molecular orbital. So that we can see according to molecular orbital theory. So we have two energy levels, that is in molecule, bonding molecular orbitals and molecular orbital. The excited state, the atom or molecule is likely to undergo a chemical reaction. So in excited state, the atom or molecule is likely to undergo a chemical reaction. Yes, sir. Yes, students, mute your
Please mute yourself.
mute చేసుకోండి అమ్మా
Abhi,
ఎవరు.
please mute. Please mute.
The next point is, so we can classify the in photochemistry which involving the photon, that is light, electromagnetic radiation. So there are two types, photophysical processes and photochemical processes. Now similar to physical change, chemical change in thermal reactions, here some photophysical processes takes place by absorbing radiation or light. In this process, it absorbs light without undergoing any chemical change. Okay, so there will not be any chemical change in the photophysical processes. So without chemical change, the absorption of light takes place. If the absorbed light is energetic, then the electron jump to other orbits or may even leave the atom. మనకి ఇక్కడ లైట్ అబ్జార్బ్ చేసుకోవడం వల్ల electrons jumps from one orbit to other orbits. Sometimes if it absorbs more energy, even it leaves the atom. So that is, we call it as ionization energy. The neutral atom, when it loses electron, that means it leaves from the atom, so that we can get a ionized electrons or positive ion will form. If absorbed light is emitted instantaneously, it is called fluorescence. So you might have studied fluorescence, phosphorescence, the Jablonski diagram, etc. అంటే మనకు absorbed light, emitted light instantaneous గా ఉందనుకోండి. So then that process is called fluorescence. Okay, now absorbed light, emitted light. Absorbed light is emitted instantaneously. So it is called fluorescence. And if absorbed light is emitted after some time gap, a few seconds, here in the first case, instantaneously, immediately. That process is called fluorescence. But if the absorbed light is emitted after some time gap, it is called phosphorescence. Simple way to remember these two processes: fluorescence, phosphorescence. And again, these two will discuss in later in Jablonski diagram. And let us see the photochemical process. So in presence of light, H2 and chlorine combines in gaseous state and forms HCl gas. One molecule of H2 and one molecule of chlorine gives 2 molecules of HCl. Or otherwise, 1 mole of one mole of H2 and 1 mole of chlorine forms 2 moles of HCl gas in presence of light. So this is a chemical process, chemical change. And another example, in presence of light and chlorophyll, the carbon dioxide and water combines and it gives carbohydrate. So that is nothing but a photosynthesis. So that's a natural example for a photochemical process. And let us see briefly laws of photochemistry. So there are some laws to understand photochemical processes and photochemistry that are laws of photochemistry. The first and foremost law is Grothus-Draper law. What is that? Grothus-Draper law. Two different scientists proposed this law. So according to this law, very simple statement, the light absorbed by reactants which is effective in bringing about a chemical change. అంటే ఏదైతే కెమికల్ చేంజ్ కు దోహదపడుతుందో ఆ అబ్జార్బ్డ్ లైట్ ను కన్సిడర్ చేస్తాం మనము. The light absorbed by reactants which is effective in bringing about a chemical change. And that absorbed light may bring changes. That absorbed light is converted into a kinetic energy. So the kinetic energy of molecules increases. And the absorbed light may be re-emitted as we discussed earlier. The absorbed light may be re-emitted as fluorescence or phosphorescence. Fluorescence means instantly, immediately. So phosphorescence means after some time gap. Isn't it? And the absorbed light is transferred from one substance to another. As a result, chemical change is observed. Chemical change is observed. So that is photosensitization. That means the absorbed light, the one molecule absorbs light, it sensitizes other molecule. So the other molecule directly cannot absorb light. The initial first molecule absorbs light, it sensitizes the other molecules. The absorbed light is transferred from one substance to another. As a result, chemical change is observed. So that is nothing but a photosensitization. So these points we'll observe in Grothus-Draper law. Okay, is it clear, dear students? Am I clear?
Yes, sir. Yes, sir.
Okay. So let us move to other laws. Stark-Einstein's law of photochemical equivalence. So these are fundamental principles to understand the photochemistry. In a primary photochemical process, each molecule is activated by the absorption of one quantum of radiation. That is one photon. Means one molecule absorbs one photon. Okay. In a primary photochemical process, each molecule is activated by the absorption of one quantum of radiation. That is one photon. So suppose n number of molecules absorbs n number of photons, or otherwise Avogadro number of molecules. Generally, we say 1 mole means Avogadro number. So what is the value of Avogadro number?
0.022 into 10 power 20.
So this much number of molecules have to absorb n number of photons. That is according to Stark-Einstein's law of photochemical equivalence, where in primary photochemical process, the number of molecules activated is equal to the number of quanta absorbed. Quantum is singular, quanta is a plural. And Avogadro number of molecules absorbs Avogadro number of photons, isn't it? So that 1 mole of quanta is called nothing but a 1 Einstein. So both Einstein and Stark explained this law. Okay. So E equal to H nu for one molecule. And E equal to N0 H nu for Avogadro number of molecules. Now the energy of photon, so by simplifying or by substituting in this equation, Avogadro number NhC by lambda, where lambda is the wavelength in angstrom units. So 2.86 into 10 power 8 by lambda calories per mole. Remember these equations. I will also share these points, these notes in WhatsApp group, so that based on this formula, we can expect numerical questions, problems.
Thank you, sir.
Similarly, if you want to calculate in joules, again, the equation becomes 119.7 in 10 power 7 divided by lambda, which is in angstrom units. Now the shorter the wavelength, greater will be energy absorbed, because the energy and lambda are inversely related, inversely proportional. Another point is quantum efficiency. Frequently we come across this word, quantum efficiency, quantum yield in photochemistry, besides all other points as we discussed earlier. ఇది కూడా మనం ఫ్రీక్వెంట్ గా వస్తుందమ్మా, క్వాంటమ్ ఈల్డ్ అంటుంటాం, quantum efficiency. What actually quantum yield? Let us see. Let us understand about a quantum yield. which is denoted with psi, number of molecules that react by number of quanta of radiation absorbed. A simple relation. Number of moles that react, number of Einsteins of radiation absorbed. So if you take molecules, quantum or photons, or if you take moles, we have to take Einsteins to the terminal. So the value of 1 Einstein of radiation, whose wavelength is 2000 angstrom units. Simply we can calculate
Sir,
the
quantum
value of
sir.
quantum yield.
Yes, sir.
No. So this is a mathematical expression. అంటే మనకి ఇక్కడ ఒక ఫోటాన్ ఒక మాలిక్యూల్ అబ్జార్బ్ చేస్తుంది. The number of photons of radiation absorbed and number of molecules that react. Theoretically, one molecule absorbs one photon, but it will be different when it comes to practically. So that we'll discuss later examples. But according to Stark-Einstein principle, oka molecule oka photon absorb chesukovali. But అంటే ఇక్కడ 1 by 1 అయితే ఎంత అవుతుందమ్మా ఇక్కడ ఒక ఫోటాన్ ఒక మాలిక్యూల్ అబ్జర్వ్ చేసుకుంటే the ratio will be 1. Quantum yield should be 1. But it should not be 1 in all cases. Okay, less than 1 ఉండొచ్చు, more than 1 ఉండొచ్చు. That is, quantum yield will be very less than 1 or more than 1, or very low or very high. So theoretically, according to Stark-Einstein, so this is the quantum yield, quantum efficiency. And the number of moles that react. Okay. ఎప్పుడైతే మోల్స్ తీసుకుంటామో we have to consider Einsteins. అంటే ఇక్కడ మోల్స్ అంటే మనం 1 mole equal to suppose 1 mole of molecules, Avogadro number. Avogadro number of molecules should absorb Avogadro number of photons, that is Einsteins.
Yes,
Okay,
sir.
is it understood?
Yes, sir.
Now let us see simple calculation which involving the value of 1 Einstein of radiation whose wavelength is 2000 angstrom units. ఓకే, ముందుగా ఇక్కడ మనకు ఎనర్జీ రావాలంటే ఈక్వేషన్ యూజ్ చేయాలమ్మా. అది వేవ్ లెంత్ ఇచ్చినప్పుడు E ఈక్వల్ టు hc by lambda.
Yes, sir.
You know the Avogadro, Planck's constant 6.62 into 10 power minus 34 joule seconds. అంటే ఇక్కడ మనం జౌల్స్ లో తీసుకుంటే ఎనర్జీ జౌల్స్ లో వస్తుంది కదా.
Yes, sir.
అప్పుడు జౌల్స్ లో మన వెలాసిటీ మీటర్స్ పర్ సెకండ్ లో తీసుకున్నాం అనుకోండి. ఇప్పుడు లాంబ్డా దేంట్లో తీసుకోవాలి, మనము మీటర్లో తీసుకోవాలి కాబట్టి దాన్ని కన్వర్ట్ చేసుకోవాలి. 2000 into 10 power minus 10 meters. So simply by substituting all these values, we'll get the value in joules. So after calculation, we'll get this value 9.9 in 10 power minus 14 joules. You can do it later. Okay. You can check later by calculating. Now the energy of this radiation, this wavelength is this photon, this joules of this wavelength. Now the question is the value of 1 Einstein of radiation. 1 ఐన్స్టీన్ అంటే ఎంత మనకు 1
One
mole.
photon into
1 mole of
Avogadro
photons.
number.
So value of Einstein equal to 1 photon into Avogadro number, that is 6.023 in 10 power 23. Okay. So the value of Einstein is 59.87 in 10 power 7 joules. Now we can convert into kilojoules by dividing with 10 power 3. 1000. So 1 kilojoule equal to 10 power 3 joules, or 1 joule equal to 10 power minus 3 kilojoules. Now, these are some examples where the photochemical reactions and quantum yields. Simply remember these examples. You can expect directly some questions in entrance exam. Now, quantum yield is small integer, that is 1, 2, 3, etc. The decomposition of acetone, which gives ethane and carbon monoxide, where the quantum yield is 1. And the formation of SO2Cl2. What it is called SO2Cl2?
Cyanide chloride.
Sulfuryl chloride. Cyanide chloride is SO4Cl2. This is sulfuryl chloride.
Okay, sir.
Where the quantum yield is 1. That is experimentally proved. And the decomposition of HBr, the quantum yield is 2. Decomposition of HI, also quantum yield 2. Because the number of molecules, number of moles is 2, number of molecules also 2. Now here the formation of ozone, in synthesis of ozone from oxygen, where the quantum yield is 3. These examples which shows quantum yield is a small integer like 1, 2, 3. Examples have a very high quantum yield. The formation of HCl from hydrogen and chlorine, where the quantum yield is 10 power 6 to 10 power 4. Means 1 photon is absorbed by 1 million of molecules. 10 power 6. అంటే మనకి ఇక్కడ ఈ రేషియోలో number of photons ఉన్నారు. Quantum yield will be more than 1. ఎక్కువ మాలిక్యూల్స్ తక్కువ కాంతిని అబ్జార్బ్ చేసుకున్నాయి అనుకో. 10 power 6 molecules absorbs 1 photon. That's why it has very high quantum yield. These two examples represents very high quantum yield. Another example is COCl2, the carbon monoxide in chlorine, it gives COCl2, where the quantum yield is 10 power 3.
సార్ దీనిలో క్వాంటమ్ yield ఎట్లా తీసేస్తారు?
అదే చెప్తున్నాను కదా, ఎక్కువ మాలిక్యూల్స్ తక్కువ సంఖ్యలో ఫోటాన్ అబ్జర్వ్ చేసుకున్నాయండి. 10 power 6 అన్నాం, 10 power 6 to 10 power 4. అంటే ఈ రియాక్షన్, విచ్ రియాక్షన్? ఫార్మేషన్ ఆఫ్ HCl ఫ్రమ్ H2 and chlorine. ఓకేనా? in this reaction, more number of molecules absorbs less amount of light. That's why its quantum is very high, very large. Now take these two examples. We have very low quantum yield. So depending on the nature of reactants and what do you call the chain reaction takes place. Chlorine and chlorine decomposes, it gives chlorine atom, and which is an exothermic process. So that the released energy is absorbed by other molecules. So that's why its quantum yield is very high. Whereas in this example, bromine in chain reaction, bromine atom, it is an endothermic process. So that's why these have very low quantum yield. అంటే ఎక్కువ కాంతి తక్కువ మాలిక్యూల్స్ అబ్జర్వ్ చేసుకుంటాయి. ఎగ్జైట్ కావడానికి ఎక్కువ శక్తి అవసరం అవుతుంది, ఎక్కువ కాంతి అవసరం. That's why these two have very low quantum yield. The small amount of light absorbed can bring about a large amount of reaction. A large amount of light absorbed brings about only small amount of reaction. Adi the high quantum yield, low quantum yield lo ila jarugutundi. Okay na? Any doubt? Anybody?
sir.
Any one of you?
No, sir.
Now let us see the other mechanisms in photochemical reactions. So the primary process, atom or molecules absorbs photon. It gives excited atom or excited molecule. The excited atom or molecule behave in different ways. The molecule breaks up into atoms or radicals on absorption of photon. The electronic transitions from a stable ground state to stable excited state, so no direct dissociation of molecule. Second step, the excited transitions from a stable ground state to a stable excited state. Excited state, second excited, third excited. Excitation takes place. So the molecule is raised to a higher level. Then at that stage, the molecule would undergo dissociation. The transition occurs from the lower level to a stable upper level. During vibration, the molecule may shift from stable state to unstable state. So ఈ పాయింట్స్ అన్ని మనకు ప్రైమరీ ప్రాసెస్ లో అబ్జర్వ్ చేస్తాం. And in secondary process, the excited molecule during the primary process may undergo. It may react to form the final product. అక్కడ ప్రైమరీ ప్రాసెస్ లో జరిగిన ఎగ్జైటెడ్ molecule అనేది it can convert into product. Or otherwise it can partly or fully deactivated. అంటే మన ప్రోడక్ట్ ఏర్పడవచ్చు, మళ్ళీ డియాక్టివేషన్ జరగచ్చు. సో కాబట్టి క్వాంటమ్ ఈల్డ్ అనేది డిఫరెంట్ గా ఉంటుంది. ఇట్ మే స్టార్ట్ ఎ చైన్ రియాక్షన్. సో నార్మల్ గా కొన్ని చైన్ రియాక్షన్స్ లో పార్టిసిపేట్ అవుతాయి. సపోజ్ హాలోజనేషన్ ఆఫ్ ఆల్కేన్స్. ఇది RH plus chlorine, suppose. What it gives? RCl, alkyl halides. So they undergo a chain reaction. You know, chain initiation, chain propagation, chain termination. ఇంతకుముందు టేబుల్లో చూసాను చూడండి, ఈ క్వాంటమ్ ఈల్డ్ రెండు అంటే వాట్ డస్ దట్ మీన్? ఫర్ 1 photon 2 molecules are decomposed. ఈ ఎగ్జాంపుల్ ఇంతకుముందు చూసినట్టు ఫార్మేషన్ ఆఫ్ HCl. క్వాంటమ్ ఈల్డ్ ఏమన్నాము? 10⁶ to 10⁴ కదా. ఇట్ అండర్గోస్ చైన్ రియాక్షన్. ఇక్కడ ఏర్పడిన క్లోరిన్ H2 తో రియాక్షన్ అయ్యి HCl + H. ఇట్స్ అన్ ఎక్సోథర్మిక్. వెరీ ఇంపార్టెంట్ పాయింట్. అంటే ఒకటి ఎక్కువ ఉండేవాడు తక్కువ ఎందుకు ఉంటుంది అనేది ఈ పాయింట్ ద్వారా మనం ఎక్స్ప్లెయిన్ చేయవచ్చు. ఇక్కడ ఏర్పడిన క్లోరిన్ H2 తో రియాక్ట్ అవుతుంది కదా. రియాక్టర్ ఏమైంది ఇక్కడ? HCl and H, which is an exothermic. నెక్స్ట్ దీంట్లో చూడండి, సేమ్ బ్రోమిన్ ఏర్పడుతుంది, H2 తో రియాక్ట్ అయ్యి HBr and H గా మారుతుంది, బట్ ఇట్ ఈస్ ఎండోథర్మిక్. సిన్స్ ఇట్ ఈస్ ఎండోథర్మిక్, ఇట్స్ క్వాంటమ్ ఈల్డ్ ఈస్ వెరీ లో. ఓకేనా? ఇంతకుముందు అడిగారు చూడండి క్వాంటమ్ ఈల్డ్ ఎలా వచ్చిందని. సో దిస్ పాయింట్ వీ కెన్ ఎక్స్ప్లెయిన్. Am I clear?
Yes, sir.
Any one of you respond.
Yes, sir.
Right. So let us move to some other points. In presence of O2, the chain may be terminated. అంటే ఇక్కడ ఒక డౌట్ రావచ్చు, చైన్ రియాక్షన్ కాబట్టి ఎట్లా స్టాప్ చేయడం? హౌ టు స్టాప్ దట్ చైన్ రియాక్షన్? సో వి యూజ్ ఫోటో ఇన్హిబిటర్స్. ఓకే, suppose if you use oxygen, it stops the propagation of H by forming HOO radical, HOO free radical. So in presence of O2, the chain may be terminated. Now quantum yield of H2 and bromine can be increased with increase in temperature, because this step is endothermic. So if we supply temperature, then its a quantum yield may increase. A singlet and triplet state. molecule absorbs UV or visible light, the electrons are promoted from ground state to higher energy state. In ground state, the spins of electrons in each molecular orbital are paired. మామూలుగా 2 electrons ఉన్నప్పుడు paired up ఉంటాయి. In higher energy state, if the spins of electrons are paired, it is excited singlet state. The pair of electrons ఉంటే excited singlet state అంటారు. If the spins are parallel, it is in excited triplet state. ఇలాగానే క్లాక్ వైజ్ గానే యాంటీ క్లాక్ వైజ్ ఉన్నప్పుడు ఎగ్జైటెడ్ ట్రిప్లెట్ స్టేట్. So the highly probable transition due to absorption of quantized energy involves the promotion of one electron from the HOMO to lowest unfilled LUMO. అంటే ఈ ఎగ్జైటేషన్స్ అనేవి from HOMO to LUMO అనేది పాసిబుల్ అవుతుంది. Now spin forbidden transitions. Now we use this another terminology, spin allowed, spin forbidden transitions, and symmetry forbidden transitions. The transitions in which the spin of an electron changes are not allowed. So in some cases, transitions which the spin of an electron changes are not allowed. They are called spin forbidden. Suppose singlet to triplet, triplet to singlet are called forbidden. Now singlet to singlet, triplet to triplet are allowed. So this is not singlet, triplet to triplet. Then symmetry forbidden transitions. The transition is related to geometries of lower and higher energy molecular orbital and also on the symmetry of molecule. So let us say a benzene is symmetrical. Many restrictions apply to the electronic transitions in simple absorption spectrum. For an unsymmetrical molecule, no symmetry restrictions. So transitions may observe among all molecular orbitals. So complex electronic absorption spectrum. So here we'll get a simple absorption spectrum. Here we get a complex electronic absorption spectrum. So these points with respect to singlet, triplet, and symmetry forbidden transitions, spin forbidden transitions. Now you might have studied repeatedly the Jablonski diagram. Now what we understand from Jablonski diagram? Simply the energy levels, ground, excited states, and transitions. The transitions from ground state to excited state and emission from excited state to ground state. Now this is singlet ground state. First excited singlet state, second excited singlet state, excited triplet state. Internal conversion. S1 to S0. S0 to S1, S1 to S0. Yes. Then inter-system crossing, where S2 to T2 or S1 to T1. Now here you can see the fluorescence. Absorption emission takes place instantaneously. The emission of radiation is rapid. In how much time? 10 power minus 3 to 10 power minus 8 seconds. That is fluorescence. And then phosphorescence. What is phosphorescence? Any one of you respond?
Sir, observe
Emission will be
చేసుకుంటారా
lag.
electron?
Spin change. Light energy.
Takes place?
Emission will be lag.
Lag.
Absorbed light is emitted after some time, sir.
Some time gap. How much time gap? Nearly 10 power minus 4 to 100 seconds. Here in fluorescence, instantaneously. Okay, that's enough. Then Beer-Lambert's law. So this also we frequently come across. మనకు frequently వచ్చేటువంటి principle. ఇది స్పెక్ట్రోస్కోపీలో కూడా వస్తుంది. Lambert Beer's law or Beer-Lambert's law. Any one of you tell me what is Lambert-Beer's law? What we understand from Lambert-Beer's law? Any one of you unmute yourself and respond.
The decrease in the intensity of emitted light is directly proportional to the concentration of solution and the length of the.
Very good, very good. So absorbed light అనేది మనం తీసుకునే సొల్యూషన్ మీడియం కాన్సంట్రేషన్ మీద డిపెండ్ అవుతుంది, లెంత్ ఆఫ్ ద మీడియం మీద డిపెండ్ అవుతుంది. ఓకే, మనం ఏదైనా లైట్ను ఏదైనా సబ్స్టాన్స్ గుండా పంపించినప్పుడు ఆ సబ్స్టాన్స్ యొక్క కాన్సంట్రేషన్ మీద డిపెండ్ అవుతుంది అండ్ ఆల్సో లెంత్ ఆఫ్ దట్, అంటే అది ఆ లైట్ ఎంత దూరం ప్రయాణిస్తుంది, ఎంత దూరం ట్రావెల్ చేస్తుంది. సో దట్ ఈస్ నథింగ్ బట్ Beer-Lambert's law. In a simple way you can understand. And that Lambert-Beer's law we can also say experimentally, by we can calculate or we can observe by using colorimetry. So absorbance equal to the mathematical equation epsilon C into L, or OD equal to epsilon CL. What is the optical density? We can get the graph between concentration and optical density. When the concentration increases, optical density increases. We'll get a straight line. And here epsilon is the molar extinction coefficient, C is the concentration of solution, L is the length of medium in centimeters. Now another expression for Lambert-Beer's law. Intensity of transmitted light equal to intensity of incident light into 10 power minus epsilon C T, where T is the thickness of the medium. C is the concentration of solution. Let us say simple questions. Many questions the model questions. You can also practice other questions. 1 mole of molecules absorbs how many number of photons?
Avogadro number of
Avogadro number of, sir. 2,
And
sir.
0.023 into 10 power
Option
26
2.
photons.
And the energy of one quantum is equal to?
4,
All
option
the
4.
above.
Yeah,
All,
very
sir.
good.
All, sir.
According to Stark-Einstein law, the expected quantum yield is
0.
Less than
Zero.
1.
1, fourth option. Theoretically, according to Stark-Einstein law, the quantum yield should be 1. Because one molecule absorbs 1 photon of radiation. And the quantum yield of the following reaction.
2, option 4, sir.
Option 4.
Very simple. This type of questions should practice. And let us say another one, not simple, but if we understand, it will be easy. The molar extinction coefficient of phenanthrolene complex of iron 2 is 12,000 decimeter cube per mole per centimeter. And the minimum detectable absorbance is 0.01. Absorbance is 0.01. The minimum concentration of the complex in molarity that can be detected in a Lambert-Beetz law. Cell of the path length is 1 centimeter. Understand the question carefully. ఒక కాంప్లెక్స్ ఇచ్చాడమ్మా, దాని యొక్క అబ్జార్బ్ మరి ఇదేంటిది 12,000 డెసిమీటర్ క్యూబ్ పర్ మోల్ పర్ సెంటీమీటర్.
Coefficient ఇచ్చింది, sir.
యా, మోలార్ ఎక్స్టింక్షన్ కోఎఫిషియంట్. ఎప్సిలాన్ ఇచ్చాడు.
Absorbance కూడా ఇచ్చింది, sir.
వెరీ గుడ్. అబ్జార్బెన్స్ ఇచ్చాడు. పాత్ లెంత్ ఇచ్చాడు, మీడియం పాత్ లెంత్. దెన్ వాట్ యు హావ్ టు క్యాలిక్యులేట్?
Concentration.
Very good. Concentration. You can use this equation. Absorbance or OD equal to epsilon C into N. Since all are in same units, you can directly substitute. 0.01 equal to 10 power 3 to 6 to 1. Now by simplifying, you will get a concentration 8.33 into 10 power minus 7. First option. Okay, shall I repeat this problem?
Yes, sir.
The Lambert-Beetz law, epsilon absorbance equal to epsilon CL. So in this problem, absorbance is given, molar extinction coefficient is given, length of the medium is also given. Now we have to calculate the concentration. Absorbance is how much? 0.01. Molar extinction coefficient is 12 into 10 power 3. 12,000 means 12 into 10 power 3. Concentration we have to calculate. Length is 1 centimeter.
Sir, option C వస్తుంది, sir. 12 into 10 to the power of 5.
లేదు సార్, ఆప్షన్ 1 వస్తుంది.
ఇది 1/12 into 10 power 3 కదా. ఇక్కడ C equal to 10 power minus 2 divided by 12 into 10 power 3. 1 by 12 into 10 power minus 5. Divide 1 with 12. Okay, na? Okay, is it clear?
Yes, sir.
Now the other boy. Is it clear?
Yes, sir. Clear.
Another simple question. In which of the following photophysical processes inter-system crossing takes place?
Fluorescence.
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 Phosphorescence.
Phosphorescence. Fluorescence అంటే ఇన్స్టంటేనియస్ కదా. Phosphorescence అంటే టైం గ్యాప్ కాబట్టి S1 to T1, T1 to S0. Jablonski diagram. Okay, na? So with this, we'll complete this photochemistry.
Excuse me, sir.
So any other doubts? Anything you want to?
No, sir.
I will share this notes. You can go through these points and practice more questions. Take 1 or 2 minutes break. I will join within 1 or 2 minutes. Okay, let us continue. Screen కనబడుతుందమ్మా?
Yes, sir.
So let us discuss another topic, surface chemistry with the colloids. We can expect one or two questions from this topic. Mostly theoretical, not numerical problems. So we'll discuss this topic. Now try to understand what are colloids and what aspects we have to remember in surface chemistry. Now we say colloids and crystalloids. Now depending on the size of that particles, we can classify crystals and colloids. The first scientist who classified the substances into two types based on their diffusion is Thomas Graham. The first type quickly diffused. Now, based on diffusion phenomena, the substances, one type of substances are crystalloids, and the second type of substances are colloids. The colloids slowly diffuses. Colloid slowly diffuses. But later on, it is observed that it is not true particular substance behaves crystalloid or as well as colloid. Suppose sodium chloride in water is crystalloid. But if we take another medium, that is benzene, it behaves as a colloid, which means the diffusion cannot take place of sodium chloride when we take in benzene. So which means it behaves differently in different mediums. The same sodium chloride, which is a crystalloid in water, but in benzene, it is a colloid because it cannot mix, it cannot dissolve in benzene, which is a non-polar solvent. You can take other examples. Copper, silver, lead metals in water behaves as colloids. Generally, the size of colloids is 10 to 1000 angstrom units. Now, what is the size of colloids? 10 to 1000 angstrom units. If that size is there, then it is called colloid. Any substance. Now, depending on size, we can classify the colloids. The colloids are heterogeneous in nature. It consists two phases. Since it is heterogeneous, it has two phases. Generally, colloids are colloidal solution. We call it a colloidal solution. True solution, colloidal solution. And what are that two phases? We say dispersed phase and dispersion medium. Now, similar to solute and solvent. మామూలుగా మన సొల్యూషన్స్ ఏం చెప్తాము, సొల్యూట్ అండ్ సాల్వెంట్ అంటాం. But here we use the different terms. Dispersed phase, dispersion medium. Sodium chloride in benzene colloids. What is the dispersed phase? Sodium chloride. And the dispersion medium is benzene. Suppose starch colloidal solution. The dispersed phase is starch and dispersion medium is water. Now we can classify the colloidal solution in different ways, depending based on the physical state of dispersed phase and dispersion medium. Again, which is similar to true solutions. If the dispersed phase is solid and dispersion medium is also solid, then it is called solid sol. What is that? Solid sol. Example, alloys. The dispersed phase is solid, dispersion medium is liquid. Simply they are called sol, SOL sol. Ink, paint, etc. If the dispersed phase is solid, dispersion medium is gas. That particular colloid is called aerosol. Smoke, dust in air. You'll observe this smoke, dust in air. It is nothing but aerosol. And the dispersed phase is liquid, dispersion medium is solid. Jellies. Simply they are called gels. In gels, what is the dispersed phase? Liquid, and dispersion medium is solid. If both are liquids, then they are called emulsions. That colloids are called emulsions. Example, simple natural example is
Milk.
milk. Milk is an emulsion where dispersed phase and dispersion medium both are liquids. And the classification of colloids further, we can classify as lyophobic and lyophilic. So lyophilic means the interaction between dispersed phase and dispersion medium is more interaction, attractive. So that's why it is called lyophilic. If a medium is water, then it is called hydrophilic. That lyophilic colloid is called hydrophilic colloids. Example, starch in water. Starch water అనేది colloidal solution, hydrophilic colloid, and it is lyophilic colloid. And it is reversible colloid. Means we can separate the dispersed phase and dispersion medium. So by evaporating water, we will get a dispersed phase starch. Then lyophobic colloid. The interaction between dispersed phase and dispersion medium is less. So less interaction or less attraction between dispersed phase and dispersion medium. The metal colloids. And these are irreversible. And we cannot separate dispersed phase and dispersion medium. After getting that colloid, we cannot separate. The colloids can diffuse through normal filter paper, but they cannot diffuse through parchment paper because due to their size, they cannot diffuse through parchment paper. What is lyophilic colloid? Any one of you respond?
More interaction
between dispersed phase and dispersed medium is more.
Okay, good. Example for
తెలుగులో కూడా
Starch in water is an example for lyophilic, sir.
Okay. Lyophobic colloid.
Less interaction between dispersed phase and dispersed medium. Example is metal colloids.
Which metals?
Element.
Copper, silver, lead. In water. Now you know something about Tyndall effect, Brownian motion. What is Tyndall effect?
The light is scattered by the colloidal particles present in the system, sir.
When the light falls on colloidals, the light will be scattered. Again, because of their size of the colloidal particles, the light will be scattered. The scattering effect is called nothing but a Tyndall effect. Now, normally, you can observe in theaters when the projector light falls on a screen. If any dust particles comes on that path of that light, you'll observe the scattering of light, Tyndall effect. Or normally you can observe in a day-to-day life. When any person sweeps the floor, if the dust particles floats in air, when the light falls, the Tyndall effect will be observed. These are general examples. Okay, na?
Okay, sir.
Now, another point is Brownian motion. So, what is Brownian motion? The disorder or random movement of colloidal particles. Random movement of colloidal particles is nothing but Brownian movement. So, through this phenomena, we can separate the colloidal particles. And for the stability of Sol, in Sol type of colloids, what is the dispersed phase? Sol.
Solid, sir.
Solid in liquid. For the stability of Sol, certain concentrated electrolyte is required. And the Sol contains positive as well as negative ions. Ferric hydroxide Sol, Fe+3. And if you take other solvent, chlorides are present. Fe+3 absorbs. Fe+3 absorbs Sol particles.
సార్ తెలుగులో కూడా ఎక్స్ప్లెయిన్ చేయండి సార్ ప్లీజ్.
ఇక్కడ మన Sol concentrated electrolyte is required. And to get stability, వీటి యొక్క Sol యొక్క స్థిరత్వాన్ని పొందడానికి మనకు కొంత కాన్సన్ట్రేటెడ్ ఎలక్ట్రోలైట్ అవసరం అవుతుంది. సపోజ్ ఈ Sol అనేటువంటి పాజిటివ్ ఛార్జ్, నెగిటివ్ ఛార్జ్ ను అక్వైర్ చేస్తాయి. Sol, ferric ions, chloride ions are present. And Fe+3 అనేది అబ్జర్వ్ చేసుకుంటుంది. So that it consists positive charge, or it is called positive Sol. అలాగే AS2S3 మేజర్ గా ఇట్ అబ్జార్బ్స్ S-2 సాల్ట్స్, కాబట్టి దానికి నెగటివ్ ఛార్జ్ ఉంటుంది. ఫెరిక్ హైడ్రాక్సైడ్ పాజిటివ్ ఛార్జ్, AS2S3 హ్యాస్ నెగటివ్ ఛార్జ్. ఇక్కడ ఏమన్నా మనము సాల్ అనేటువంటి పాజిటివ్ ఛార్జ్ కానీ నెగటివ్ ఛార్జ్ అయాన్స్ కలిగి ఉంటాయి. దాన్ని బేస్ చేసుకొని మనం వాటిని పాజిటివ్ సాల్, నెగటివ్ సాల్ గా క్లాసిఫై చేస్తాము. Stability of colloids. Lyophilic or hydrophilic colloids are stable. Now, why they are stable? Because the interaction is more between dispersed phase and dispersion medium. And the hydrophobic colloids are unstable. So, on addition of electrolyte, the coagulation takes place. On addition of hydrophilic salt to hydrophobic salt, it gets a stability. It is called protection of colloid. ఇక్కడ హైడ్రోఫోబిక్ కొల్లాయిడ్స్ కు హైడ్రోఫిలిక్ సాల్ యాడ్ చేస్తే వాటి యొక్క స్టెబిలిటీ పెరుగుతుంది, అవి స్టేబుల్ అవుతాయి. అలా స్టేబుల్ కావడాన్నే ప్రొటెక్షన్ ఆఫ్ కొల్లాయిడ్ అంటాం. సో వీఆర్ ప్రొటెక్టింగ్ దట్ కొల్లాయిడ్, హైడ్రోఫోబిక్ కొల్లాయిడ్, బై అడిషన్ ఆఫ్ హైడ్రోఫిలిక్ సాల్. And this the protection of colloid is measured in terms of gold number. The strength of hydrophilic salt is measured in gold number. Now, what actually the gold number means? Now, try to understand. To 10 grams of gold salt, gold salt no standard ga తీసుకొని, on addition of 1 ml of 10% sodium chloride, ఈ electrolyte ని యాడ్ చేస్తున్నాము. 10% sodium chloride electrolyte. To prevent coagulation, the required hydrophilic salt in milligrams is called gold number. So మరొకసారి చూడండి, 10 grams of gold salt తీసుకొని, సో దానికి 1 ml 10% sodium chloride. ఎందుకు 10% sodium chloride, which is an electrolyte to protect that colloid. And to prevent that coagulation, the required hydrophilic salt in milligrams is called gold number. The less gold number, more its strength.
సార్ మళ్ళీ ఒకసారి రిపీట్ చేయరా సార్?
The gold number, huh?
Yes, sir.
So what purpose this gold number is used or measured?
Colloid strength.
Hydrophilic salt యొక్క strength ను measure చేయడానికి యూజ్ చేస్తాం. Why we have to use hydrophilic salt? to protect the colloid, to protect the hydrophobic salt. Again, hydrophobic salt కు స్టెబిలిటీ మార్చడానికి హైడ్రోఫిలిక్ సాల్ యాడ్ చేస్తాం కదా. An addition of hydrophilic salt to hydrophobic salt, it gets stability. That technique is called protection of colloid. మరి హైడ్రోఫిలిక్ సాల్ యొక్క స్ట్రెంగ్త్ గోల్డ్ నెంబర్ ఆధారంగా మెజర్ చేస్తాం. అంటే గోల్డ్ సాల్ రిఫరెన్స్ గా తీసుకొని దానికి 1 ml 10% sodium chloride which have to be taken to prevent coagulation. To prevent that coagulation, how much hydrophilic salt in milligrams is required? Is called gold number. Okay. అంటే ఈ గోల్డ్ నెంబర్ తక్కువ ఉంటే ఆ హైడ్రోఫిలిక్ సాల్ యొక్క స్ట్రెంగ్త్ ఎక్కువ ఉంటుంది, ఏదైతే మనం యాడ్ చేయాల్సిన హైడ్రోఫిలిక్ సాల్. So why we have to add hydrophilic salt?
To stabilize
Prevent
the
To
colloid.
stabilize the hydrophobic salt. Good. Now what is coagulation? మామూలుగా అయానిక్ రియాక్షన్స్ లో ప్రెసిపిటేషన్ అంటాం మనం. ప్రెసిపిటేషన్ ఫామ్ అయింది అంటాం కదా. సపోజ్ క్లోరైడ్ అయాన్కు సిల్వర్ నైట్రేట్ యాడ్ చేసాం మనం. What do we get? Silver chloride. Similarly, in colloidal solution, so instead of precipitation, we'll use this term, coagulation. An addition of electrolyte, the salt turns into precipitate. If the colloidal particles possesses similar charges, hence there are repulsions. An addition of electrolyte, అంటే సపోజ్ పాజిటివ్ సాల్ తీసుకుంటే పాజిటివ్ మధ్య రిపల్షన్స్ ఉంటాయి, repulsions. But when you add electrolyte, which consists positive as well as negative, so positive salt reacts with negative salt, so that neutralization takes place. So during that neutralization, coagulation occurs. So negative salt తీసుకున్నాం అనుకో, electrolyte positive part, negative part ఉంటుంది. So the negative part, positive part neutralizes, so that the coagulation occurs. Positive colloids will be neutralized by negative particles of electrolyte, and the negative colloids will be neutralized by positive particles of. Now another principle, Hardy-Schultz principle, which tells the capacity of electrolyte for coagulation. So the coagulation capacity of electrolyte depends on size and charge of ions. Coagulation capacity of electrolyte depends on size and charge of ions. coagulation capacity of size and charge. For example, As to S3, which is a negative salt. For coagulation, the required positive ions are either sodium electrolyte, magnesium, or aluminum electrolyte. Now, which has more strength?
Aluminum.
Which ion which possesses more charge? And ఇక్కడ
Al plus 3.
Aluminum plus 3 charge, plus 2, plus 1. So that's why this is more, what do you call? ఏమంటాం దాన్ని?
Strength.
Strength.
Aluminum plus 3 has more strength. అంటే ఇది ఎక్కువ యూజ్ అవుతుంది ఫర్ coagulation. Compared to magnesium, sodium also can be used, but the aluminum is more effective for coagulation of this negative salt. ఇది పాజిటివ్ సాల్ట్, ఇది ఫెర్రిక్ హైడ్రాక్సైడ్. మరి ఫెర్రిక్ హైడ్రాక్సైడ్ కోయాగులేషన్ చేయడానికి నెగిటివ్ అయాన్స్ కావాలి కదా, ఎలక్ట్రోలైట్. ఏ నెగిటివ్ అయాన్స్ ఉన్నటువంటి ఎలక్ట్రోలైట్ వాడతామో ఇవన్నీ వాడచ్చు. what is the first one? Ferrate 2 ion.
Ferrate 2
కదా, 2 కాదా?
2 sir. Ferrate 2 oxidation 2.
2
Right. Phosphate, sulfate, chloride. So which is more effective?
Cyanide.
Because it has more charge, more negative charge. Now from these points we can expect questions. Let us see emulsions. What are emulsions? What are emulsions?
Liquid in liquid, sir. Liquid dispersed in liquid medium.
Okay. So let us go through quickly. Milk is an example. And there are two types: oil in water, water in oil. The dispersed phase is oil, which is in liquid state, and the dispersion medium is water. Milk, fat in water. And water in oil. Dispersed phase is water, and dispersed medium is oil. Cheese, cod, liver oil. You can see these examples. And let us understand some of the applications of colloids. Now, due to small size of colloids, these are absorbed by body. The medicine use chestam because of their small size. The cod liver oil tonic ga vaadtaru. Milk of magnesia emulsions. Then purification of water. The potash alum is used for purification of water. Coagulation takes place. Coagulation of impurities takes place. And tanning in leather industry, proteins are positive colloids on skin. Due to negative particles of tannin, coagulation takes place. Leather tanning అంటారు కదా, ప్రోటీన్స్ అనేటువంటి పాజిటివ్ కొలాయిడ్స్ ఏది స్కిన్ లో పైన ఉన్నట్టు. When we use negative particles of tannin, the coagulation takes place. Neutralization జరుగుతుంది. The blood is colloid which is a negative charge. To prevent bleeding, alum is used. మనము ఆలం అంటే పట్టిక అంటారు కదా, బ్లీడింగ్ ఆపడానికి రక్తం గడ్డగట్టడానికి పొటాష్ ఆలం ఉపయోగిస్తాం. బికాస్ blood is negative colloid, negative charge colloid, -3 positive charge. Coagulation of blood takes place. Now, in artificial rains, oppositely charged dust and sand are sprayed on cloud so that the precipitation takes place upon water molecules. Now, this points with respect to colloids up to here. Okay, let us continue. Shall we continue?
Yes, sir.
Yes, sir.
No. Now, another phenomena, adsorption. AD. Absorption is different, adsorption is different. Now, how we can understand adsorption?
Accumulation of substances on the surface.
Very good, very good. Only surface phenomena. It is not a bulk phenomenon. Accumulation or concentration of a substance over other substance superficially or in surface only. If the concentration takes place inside, it is called absorption. To some extent, we call it as adsorption, but in below that, it is called absorption. So ammonia gas is dissolved in water, which is absorption. Ammonia, same ammonia, which adsorbs on charcoal, which is a surface phenomena. That is called adsorption. And again in adsorption, adsorbent, adsorbate. Again similar to dispersed phase and dispersion medium or solute and solvent. Adsorbent is charcoal, adsorbate is ammonia. Now, adsorption is two types, physical adsorption, chemical adsorption. Now, let us quickly understand the physical adsorption, chemical adsorption. The physical adsorption is exothermic process. It releases little amount of energy, that is 20 to 40 kilojoules. So there are van der Waals forces of attraction between adsorbent and adsorbate. And adsorption is a reversible process. The physical adsorption is a reversible process. Means we can separate adsorbate and adsorbent. So adsorption of gases on solid surface, which is a multi-layered, and it takes place at low temperature and high pressure. The physical adsorption takes place at a low temperature and a high pressure. Whereas in chemical adsorption, there are chemical forces involved, chemical attractions involved between adsorbate and adsorbate, which is also exothermic, but here large amount of energy releases. How much? 40 to 400. Here 20 to 40 kilojoules. and it is a irreversible. Adsorption of H2O2 CO on metals, which is a chemical adsorption. It takes place at a high temperature and pressure. Sorry, it takes place at a high temperature and pressure has no effect in case of chemical adsorption. But in case of physical adsorption, it takes place at low temperature, high pressure. Effective adsorption takes place at high pressure, low temperature. And it is a unilayered process. So all these points you might have studied, but let us recall and remember so that it will be useful in your entrance exam. So factors affecting adsorption. Nature of adsorbent. Adsorption depends on solid adsorbent. So various gases adsorb differently on solid surface. Adsorption increases with surface area. Silica gel, charcoal are good adsorbents due to porous in nature and more surface area. The nature of adsorbate. Easily liquefied gases, CO2, ammonia, HCl adsorbs more on solid surface. The gases like O2, H2, N2 adsorbs less because they are not easily liquefiable gases. These are not easily liquefiable gases. These are easily liquefiable gases. Why? Tell me the reason why these are not easily liquefiable gases. These are more easily liquefiable gases. Any one of you?
Strong ionic bond.
No, these are light gases due to their less molecular weight. These have more molecular weight and also more attractive forces. These have weak van der Waals attractions. Effect of temperature. Adsorption is an exothermic process. According to Leach principle, at high temperature, equilibrium shifts towards left hand side. Exothermic equilibrium అనేది left side కి shift అవుతుంది. So what are the favorable conditions? Low temperature. Temperature more absorption. And the effect of pressure. At a constant temperature, adsorption increases on increasing pressure. At 0 degrees Celsius, minus 29, minus 78. On increasing pressure, the mass of adsorbed gas increases exponentially. So at low temperature, low pressure, adsorption is less. On increasing pressure, adsorption increases. After that, it remains constant. చూడండి, కొంత ప్రెషర్ తర్వాత మనం ఎంత ఇంక్రీజ్ చేస్తే అబ్జార్ప్షన్ అనేది కాన్స్టెంట్ గా ఉంటుంది. Then Freund-Leach adsorption isotherm. X by m equal to K into P to the power of 1 by n. X is the mass of adsorbate, M is the mass of adsorbent. K, N are constants. At the low pressure, X by M proportional to P. At high pressure, X by M equal to K. Now, by modifying this equation in terms of logarithms, log X by M equal to log K plus 1 by N log P. So, Y equal to Mx plus C. Mx plus C. Log X by M versus log P. We'll get a slope with the intercept log K, where slope is a 1 by N. This is Freund-Leach adsorption isotope. And then Langmuir adsorption isotope. So which gives relation between adsorbed amount and pressure. Adsorbed amount and pressure. Solid surface is homogeneous. It consists adsorption sites. And adsorption takes place unilayered. Adsorption is a reversible process. In forward step, condensation of gas takes place on solid surface. In backward step, evaporation of gas takes place on solid surface. The equilibrium attains when the rate of forward step equals to rate of backward step. Now here, mathematically the Langmuir adsorption isotope X by M equal to K into theta, where theta equal to BP by 1 plus BP. B is a constant. So by substituting, we'll get this equation. X by M equal to KBP by 1 plus BP. Suppose if you take KB equal to A, AP by 1 plus BP. X is the mass of gas, M is the mass of solid, theta is the area of gas adsorbed. And this equation dividing with P, X by M by P equal to A by 1 plus BP. If you reverse this equation, P by X by M equal to 1 plus BP by A. So P by X by M equal to 1 by A plus B by A into P. Now again Y equal to Mx plus C. P by X by M versus P. So we'll get B by A by slope. Now at low pressures, 1 is very, very more than BP. Equation. Theta equal to BP by 1 plus BP. So the equation becomes theta equal to BP. What is theta? Any one of you?
Constant.
Theta is the area of gas adsorbed. Theta. AB are constant. Theta is not a constant. In another case, at a high pressures, BP is very much greater than 1. So we cannot ignore in denominator. 1 can be ignored. So X by M equal to AP by 1 plus BP. X by M equal to AP by BP. So PP gets cancels, A by B. So X by M is independent of P. At a moderate pressure, X by M is proportional to P to the power of N, where the N value is 0 to 1. Now let us see quickly the applications of adsorption. To create vacuum, in Dewar flask, coal adsorbs gases so that it creates vacuum. Dewar flask అనేది మనకు ఇది ఐడియల్ గ్యాసెస్ సెపరేషన్ లో వస్తుంది. ఆ గ్యాసెస్ అబ్జార్బ్ చేసుకోవడం వల్ల వాక్యూమ్ ఏర్పడుతుంది. And in paint industry, spirit is used as wetting agent. Spirit, that is ethanol is used as a spirit, which is a wetting agent. Solid, liquid, gas layers are removed by adsorbents. And in softening of hard water, you know, zeolite is used in softening of hard water. It adsorbs calcium, magnesium ions. These ions are responsible for hardness of water. And that zeolite adsorbs calcium and magnesium. So it gives sodium plus ions. The hardness can be removed by zeolite. The ions can be removed by zeolite by adsorption phenomena. And the next one is removal of colored impurities. In the manufacture of sugar and vinegar, colored impurities are removed by charcoal. The colored matter adsorbs on charcoal so that the sugar crystals can be obtained in white crystalline solid. And in catalysis, adsorption of reactants takes place on catalyst, hence it gives products. Okay. Again, read these points in a colloids and surface chemistry. Now let us see some model questions. Okay. Number of phases present in colloidal solution.
Two phases.
Colloidal solution, is it heterogeneous or homogeneous?
Heterogeneous.
Yeah. The colloids are purified by
Dialysis.
Filtration.
Filtration.
no Brownian motion.
సార్ మరి స్టార్టింగ్ లో ఫిల్టర్
పార్చ్మెంట్ ఫిల్టర్ పేపర్ ద్వారా పోవమ్మా colloids. నార్మల్ ఫిల్టర్ పేపర్ ద్వారా పోతాయి. But effectively the Brownian motion, the random movement, we can purify the
Brownian motion field separate చేయొచ్చా సార్ colloids?
purify అవుతుంది.
సార్ ఫస్ట్ క్వశ్చన్ ఆన్సర్ ఏంటి సార్?
చెప్పాలా నువ్వే.
1 phase సార్.
2 phase. Dispersed phase and dispersion medium. నార్మల్ గా రెండు ఉంటాయి. And physical adsorption is appreciably takes place at
Lower temperature.
Low temperature.
Low temperature, high pressure.
Chemizoption,
Exothermic process.
right. When a strong beam of light is passed through a colloidal solution, the light will be
Scattered.
Scattered.
for the precipitation of a negatively charged arenaceous sulfide. Which of the following is more effective?
A.
Al
C, sir.
plus
C, sir.
Al plus 3, sir.
Al plus
Aluminium ion.
In terms of amount of substance as absorbed per gram of the absorbent H by M. The pressure of the gas, the point is absorption isotherm is represented as.
X by M is equal to K into P power 1 by N.
Yeah, very simple.
Option 3.
Okay, any doubts? Anything you want to ask?
Sir, please share the PDF in the group, sir.
Sir, phase rule చెప్పండి sir.
Pedro, day after tomorrow is. When you have exam entrance?
11th.
11th, sir.
August 11th.
Chemical equilibrium అయిపోయిందా?
Late, sir.
Sir, syllabus లో chemical equilibrium లేదు sir.
అది PDF షేర్ చేయండి సార్ గ్రూప్ లో.
Yes, sir, please.
So I'll take colligative and phase rule next class.
థ్యాంక్ యూ సార్.
Thank you,
Okay.
sir.
సార్ ఈ PPT షేర్ చేయండి సార్ PDF గ్రూప్ లో.
Okay, yes, sir.
Thank you, sir.
Thank you.
Okay, we'll close the lesson session.